Hello everyone. Welcome back to Maths class, chapter 18, Statistics. The next topic is frequency distribution. A tabular arrangement of data showing their corresponding frequencies is called a frequency distribution. In the previous class, we have learned what do you mean by tabulation and what do you mean by frequency. If the tabular arrangement is done according to the frequencies, we call them as frequency distribution. And the table showing the data means information, the message or the data, the numerical data, what we have collected is called as data. So the table showing data with their corresponding frequencies is called a frequency distribution table. So in the previous class, we came to know what is tabulation and what is frequency. Now writing the given data or the collected data in the tabular form according to their corresponding frequencies is called as a frequency distribution table. Next is ungrouped frequency distribution. We have two types of frequency distributions. First one is ungrouped frequency distribution. Just observe the image over here. This is the group of data of 19 students and the shoe sizes of the 19 students are given over here, and this data is rewritten in a tabular form. It is called as a ungrouped frequency distribution. It is converted into a frequency table with the help of tally marks, and this data is ungrouped. It is not grouped in any order. It is just rewritten in a tabular form with their corresponding frequencies. Let us see what is the next type of frequency distribution. The next type of frequency distribution is grouped frequency distribution. Consider this example. Here we have the examples of group frequency distribution, the marks of 32 students in an examination. And it is said that group this data on the basis of class interval 1 to 10. Now we are not going to write down who scored 1 marks, how many of them scored 2 marks, 3 marks, 4 marks. Now we are creating a range. How many students are there between 1 to 10? How many students are there between 11 to 20? How many students are there from 21 to 30? And how many students are there from 31 to 40? So like this, keeping a class interval as a range and to make a tabular form of data is called as grouped frequency distribution. So the basic knowledge to have in the statistics is to identify whether the given data belongs to grouped or ungrouped. Based on this, the problems will proceed with the further steps. So it is very much important to identify and recognize and also to differentiate as grouped and ungrouped. I hope by this time you might be having an idea what is ungrouped. Let me repeat it. Ungrouped data is the data which is rewritten in a tabular form without any rules and regulations. But group data is a data which is rewritten in a tabular form by considering certain range as class interval. Both these are called as frequency distribution table. Next is types of frequency distributions. We have two types of frequency distribution. One is inclusive. What is this inclusive? In an inclusive distribution, the upper limit of one class does not coincide with the lower limit of the next class. Just keep this example in your mind, children. 10 to 20, 21 to 30, 31 to 40, and so on. The second type of frequency distribution is exclusive frequency distribution. So in an exclusive distribution, the upper limit of one class coincides with the lower limit of the next class. Keep this example in your mind. 10 to 20, 20 to 30, 30 to 40, and so on. Just observe both the examples. Keep in your mind what difference you can identify in this. Okay, let me move on to next so that the problem will be completely cleared for you. Keep these examples in your mind, children. One is of inclusive, one is of exclusive. Look at the slide over here. If the given frequency distribution is of 10 to 20, 20 to 30, The first class interval, this is 10, and here in the second class interval, the first one is 20. These are called as lower limits. In a similar way, the 10 to 20 and 20 to 30, they are called as upper limits. So, hence we say that what is exclusive now? I hope by this time you got an idea of exclusive. Exclusive in the sense, upper limit of one class coincide with the lower limit of the next class. Here you can find 20 as upper limit, same 20 as lower limit in the class interval. So we also call it as continuous. 10 to 20, 20 to 30, 30 to 40, 40 to 50. Where I am going to stop? I am going to continue with the same class interval. That is 10 to 20. Here 20 is the upper limit. When I begin the next one, 20 becomes the lower limit. So this type is called as exclusive class interval. The next type is inclusive. Here you can identify 10 to 20, 21 to 30. So what happened in the inclusive case, children? In an inclusive distribution, the upper limit of one class does not coincide with the lower limit of the next class. 20 is a different value and 21 is the different value. So these two will not coincide each other. Just keep these two concepts in your mind. This is very much necessary to solve the problem. So now you should be able to identify group data, ungroup data, and then exclusive and inclusive. Let us move on to the exercise problem. Exercise 18A, question number 1. State which of the following variables are continuous and which are discrete. Let me recap what is discrete and what is continuous. A variable which can take only numerical value within a certain range is called a continuous variable, and a variable which is incapable of taking all the possible numerical values is called a discrete variable. Number of children in your class, whether is it continuous or discrete? Of course it is discrete. Why? Because it cannot accept all type of numerical data. Distance traveled by a car, it can have any numerical data, hence it is continuous. Sizes of shoes, it is discrete. And the time, it can be continuous. And number of patients in the hospital, of course it is discrete. We cannot say there are 3.5 patients or 10.2 patients in the hospital. It should have a certain particular number, hence the number of patients in the hospital is discrete. Question number 2. Given below are the marks obtained by 30 students in an examination taking class interval 1 to 10, 11 to 20, 41 to 50. Make a frequency table for the following distribution. Note down the values in your textbook, children. In this, it is said that we need to consider the class interval as 1 to 10, 11 to 20. Come on, recognize what type of class interval. It is inclusive class interval. Here, the lower limit will not coincide with any of the upper limit. They are entirely different. Just look at the table. I hope you will be knowing how to mark the tally. Tally will have the marking 1, 2, 3, 4 and slash will be marked as 5. It is one group. Try to mark the tally. Consider the frequency distribution as 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. And the given in the data we have the marks 8. First one is 8. So 8 will come under 1 to 10. Just mark it as here 1. Then 17. It will come under 11 to 20. Next 33. It will come under 31 to 40. And the same way, try to mark the tally and count the frequencies. Here we have only 4 lines. Hence the frequency is 4. Here we have 5 plus 3, it is 8. Next it is 5 plus 1, 6. This is also 5 plus 1, 6. Here also 5 plus 1, 6. Question number 3. The marks of 24 candidates in the subject mathematics are given below. The maximum marks are 50. Make a frequency distribution taking the class intervals 0 to 10, 10 to 20. It is continuous. Now, how to mark the data here? Observe the table, children. In the given distribution, if you mark, you can find here 40 and 30. Where to make 40 and 30? Here in this distribution, 40 is not included in the class interval 40 to 50, and it should be included in the class interval 40 to 50, and it cannot be in 30 to 40. That means to say we have to consider the lower limit and not the upper limit. I repeat, children, in this frequency distribution, the marks 40 are included in the class interval 40 to 50 and not in 30 to 40. Similarly, 30 is included in the class interval 30 to 40 and not in 20 to 30. Question number 4. Fill in the blanks. A quantity which can vary from one individual to another is called a variable. Sizes of shoes are discrete variable. Daily temperature is continuous. The range of data is range in the sense we need to calculate the difference between the highest, the maximum given data numerical value with the least numerical data. Among the given data over here, 25 is the highest and 6 is the smallest. So the difference between 25 and 6 is 19. In the class interval 35 to 46, what is the lower limit? Lower limit is 35 and the upper limit is 46. Now the class mark. What do you mean by class mark? Class mark means it is the midpoint of the class interval. So how to calculate the class mark? The given class interval is 22 to 29. Find its sum and divide it by 2. That is 22 plus 29 by 2. So the class mark is 25.5. Question number 5. Find the actual lower class limits and upper class limits and the mid values of all the classes. So we have 4 class interval, 10 to 19, 20 to 29, 30 to 39, 40 to 49. Which are the lower class limits, children? 10, 20, 30 and 40. Which are the upper limits? 19, 29, 39, 49. How to find out the mid values? Add and divide by 2. 10 plus 19 by 2, 20 plus 29 by 2, 30 plus 39 by 2 and 40 plus 49 by 2. Calculate, add the sum and then divide it by 2. You will get the mid values of the given class interval. Question number 6. Find the actual lower and upper class limits and also the marks of the classes. So let us find out what is this lower limit. It is 1.1, 2.1 and 3.1. Upper class limits are 2, 3.0 and 4. Again, we need to find out the class mark, add and divide by 2. 1.1 plus 2.0 by 2 is 1.55. Similar way, calculate the class mark of remaining 2 class intervals. By this, we have completed the first 6 problems of exercise. Thank you, children. Have a nice day.